Hello and welcome to my channel. Today I'm here with part 3 of multi-section solid training series. If you have watched the first two lessons, get ready for us to go deeper today. We're going straight into the core of this tool to fully review the 4 specialized coupling methods, including vertices and ratio. So get a cup of coffee, ready, open CATIA, and let's start tutorial full of professional tips. Stay with me.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every
Hello friends, welcome to lesson 3 of our training series about the super practical tool, multi-section solid in CATIA. Today we will have an important and complementary lesson about this tool. As you saw in the previous two lessons, we can connect 2 or more 2D sections using this tool. These sections or sketches are drawn on different planes, which can be parallel or perpendicular. In this tool, the software uses 4 different methods in the coupling section to connect the sections. Today we will review all these methods in detail. Coupling mode review. The first method, which we mentioned earlier, is called Tangency and Curvature. In this mode, the software tries to make the resulting surface both tangent to the sections and control the lateral surface curvature. The goal is to produce the best possible surface quality C2. This mode is a more advanced method than just the tangency state. In the tangency mode, the software only ensures that the connection of the side surfaces to the sections is tangent in a specific direction, C1. This mode is suitable for curved or circular sections. The third mode is called Vertices. This method is suitable for connecting two sections that have an equal number of vertices or corners. Even if the shape of the two sections is different, this method works. Our only condition is that the number of vertices of the two sections must be equal. Imagine we have two sketches with different shapes but an equal number of vertices on two parallel planes. I activate the multi-section solid command. In the settings window, I click on both shapes. Important notes. Be sure to place the closing points and their arrow direction correctly. If the connection mode is set to tangency and curvature, the solid might be created. Now I set the connection mode to vertices. You can see that the shape was created successfully again. Circle to a square connection example using vertices. But if we want to connect a circle to a rectangle or a square which have different numbers of vertices, first we must create 4 suitable points on the circle's perimeter using the point tool from the reference element set. Now I activate the multi-section solid command. After selecting the sections and setting the closing points, I click on the Coupling tab. I select the corresponding points on the circle and the corners of the square in order. Four green lines appear as the coupling lines. I click OK and the shape is created. Reviewing the ratio mode. The fourth mode was ratio, connection based on perimeter ratio. This mode is very useful for connecting two completely non-uniform sections. In this method, the corresponding points are found based on the position ratio on the section's perimeters. The starting point for calculating this ratio is the closing point. The software first measures the perimeter length of each profile. For example, if we have a circle perimeter 188.5 mm and a square perimeter 160 mm, the software calculates, for example, 10% of the perimeter length of each section. This 10% creates a corresponding point on both perimeters, starting from the closing point and following the arrow direction. This process is repeated for all intervals, for example 25%, 50%, 75%, and the corresponding points are connected. Section 2. Advanced Control Options. There are two important control options in the setting window for this tool. The first one is Angular Connection. This option controls the orientation and rotation of the sections along the transition path. This tool is mainly used to prevent unwanted twisting or to apply a plane rotation. If this option is active, the minimum twist will occur and the transition lines will remain as straight as possible. If it is inactive, the chance of twisting increases, especially with sections of different shapes. The next option is Deviation, which is a parameter to control the accuracy of the final geometry production. Obviously, the higher the design accuracy or lower deviation, the more precise the model will be for manufacturing or CNC programming. Section 3. Connecting 3D surfaces, boundary. Now assume we have two 3D shapes instead of two profiles or sketches that place parallel and distant from each other. We want to fill the empty space between their cross-section surfaces using the Multi-Section Solid tool. I activate the Multi-Section Solid tool. In the first part of the settings window, instead of the sketches, I click on the facing surfaces of the two volumes. You can see that the names change to Boundary 1 and Boundary 2. In the support column, the name of the selected surface on the parent part, for example Pad 2, Face 1, is recorded. I place the closing points and the direction arrow in the correct position. I click on Preview. Pay attention to the connection point of the created curve with the edges of the pads. In the default mode, Tangency, you can see that the connection is tangent. Now, in the fourth column, I right-click on Tangent and select Non-Computed Tangent. You can see that the connection status of the multi-section curve to the pad edge changes to a pointwise connection. Compare this mode with the other edge that has the tangency state. I click OK and you see the final shape. Final note: areal law. You also see an option called areal law in the settings window. This option is responsible for controlling and managing the rate of the change of the volume's cross-sectional area along the path. To precisely define the areal law and use the law feature tools, we must enter the generative shape design environment. Therefore, we will leave this option with this short explanation and plan it for a separate very advanced lesson. Thank you for staying with us until the end of the lesson. Okay, today's lesson is finished. Please watch this lesson 2 times. On the second time, practice step by step with me. Good luck. See you in the next lesson. Goodbye.
Let's build